I would like now to turn this back to you. And this time I'm going to walk around and listen, but I'm also going to limit the time. I would like at your table for you to make a list of 3 things in terms of what you think a mathematics class should look like. And then another list, what should happen in every mathematics class. So you're sitting in the back of the class, or you're walking class, or you're in the class. You're a student in the class. Every single day, what do you think this class should feel like, look like? What should be happening in the class? And from beginning to end, what's got to happen at least once every period. So see what you can do with this. I have no idea what you're going to do with this. But I'm curious. It is amazing how well one of these can model teaching. One of the important things that took me a long time to learn is that one of the things about teaching is that it is a continually recursively changing thing. That if you go in with a lockstep plan that this is what's going to happen 10 minutes into it, you're asking for trouble. You have to react and respond. I am about, in terms of what I thought was going to happen, I'm about 10 minutes into the talk now. So my expectation, I know I've got the closing, but my expectation was that I would have people write up what they thought or whatever. We go from table to table to table. I still want to get some communication, but I'm not going to take the time to write anything down. You're going to have to listen. So if somebody would volunteer to go first, and then please other people add to that if you would. Okay, somebody. Go.
It should have debate and justification.
Okay? Debate and justification. Somebody else.
Visuals and use.
Visuals and use. I can maybe write some of this down. You won't be able to read it. But... Okay? Just speak up. Yeah.
Everybody is involved. Yeah.
Technology.
And you mean everybody. No child is left behind when it comes to involvement. It's absolute. When I heard this is no child left behind, I said they finally got it right. No child is ignored. Yes.
Technology.
Can you expand on that?
Was that just using whatever tools are appropriate to the problem. Sometimes technology, sometimes visual, sometimes...
Sometimes the dot paper, just kids should be using tools that are appropriate for whatever problem.
Right. Anything else? Yeah.
Trust and respect.
And that would be, I assume, teacher to student, student to student, everybody.
Some silence so that they can just stand it out. Some kids need quiet.
I want to hear terminology.
Can I expand on that a little bit and correct notation?
Nomenclature.
Yeah, nomenclature. I would just like to comment on that because that's not something I've got planned and I'll forget it. One of the things that I learned in 41 years, and I almost learned it year by year by year by year, when I started teaching, I was looking for kids who had insight. And that was it. And if they could arrive at a conclusion, somehow, because they could see something, it wasn't important to me that they had all the details written down right. And I wasn't all that careful about correct notation, about all of that. I did have to be able to see enough so I could figure out what they were doing, but I really wasn't all that careful about the details. In fact, in those days, rigor was a bad word. because it meant you were focusing on non-essentials. You wanted to cut to the chase and get it. After virtually every year, I tweaked away at that and cut away at that and said, no, that's wrong. That just doesn't work. The kids who don't learn to write it down well never get it. They hit the wall someplace. They get to a point where they can't go to the next step. And this is particularly true in calculus. I taught calculus for a long time. And again and again and again, I saw kids, if they didn't pay attention to the details of things like the limit as x goes to 5 is equal to the limit as x goes to, is equal to the limit, is equal to. If they didn't bother to write those limits and just wrote the answer and circled it, in the end, they got blown away. They really just were learning how to do the problem, but they didn't know why. They weren't thinking into the problem. So I couldn't agree more that correct notation and correct language, the difference between equal and congruent in a geometry class. You know, I think there's a big difference. Mathematicians don't. When you hear mathematicians talk about geometry, they use equal and congruent interchangeably. So maybe at that level it doesn't matter, but for my kids, it matters. Anyway, okay, thank you. Anything that's just got to get out here on this list before we stop? Yeah.
Kind of goes to what you said. I was thinking less negative talk and recognize the successes, no matter how little they are. And I think it starts probably at kindergarten because a lot of kids are reluctant to learn math and they hate it. And it's kind of what you were saying with the other problems when we did with the square.
Yeah.
Get the problem right, they got to get something right, so that way they feel some success in math.
Absolutely.
Upper elementary, like I am, or the high school, then they are more comfortable.
However, the praise and the celebration has to be legitimate, right? You don't give everybody a sticker just because they wear clean clothes and smile.
Right, but you hear a lot of teachers say, no, that's not it. Instead of saying, yeah, you got that right. Why don't you try to talk to the group and work this?
Interesting idea. We may come back to that one. One of the things that happens at the College Board AP grading is there's no negative points. You give points for doing correct work. You don't take off points ever. If they write this, if they show you that they know this, they get some points. If they do this part, they get some points. If they do this part, they get some points. That's it. You get points for doing mathematics. There's no -5. Yeah.
Using great application projects where they're collecting data and analyzing it and then writing reflections about it. Yes, long-term projects. That makes sense to me.
Okay. Now, I'd like you to listen to me for a little bit. I agree with everything you've said. And I think we could do this for another half hour if we wanted to, and we'd come up with a legitimate list. I suspect that as we went on, what would happen is we'd get more specific details and less generalizations. But we could do it. I would like to refer at this point, so the question is, how do you make this happen? And there's two questions here for you. Number one is, how do you make this happen? Monday in your class. And perhaps equally as important and more important for this group is, how do you help other people make this happen? Because a lot of you are in supervisory positions and a lot of you are working with younger teachers. A lot of you already know how to make some of this happen, but how do you help other people make it happen?